Mic on, can I be heard? I was told it was on remotely, but I don't know if it's on in the room.
It is on in the room.
Fantastic. So all the little approach a bit. Okay, so that means all the conversation we had, not knowing the mic was on, the open mic conversation we had was not heard in the room. I suppose I should be relieved. Good morning. I guess we should start. We've got is the agenda up? Yes, the agenda is up. So first I'm going to start by asking, is there anyone that is willing to be a Jabber scribe? And if you were listening to the conversation, you know that I wasn't able to get Jabber running on the iPad, and I'm not sure why. Okay, thank you. Is there anyone that's willing to take the notes on the page? Anyone? I see no one volunteering. There must be someone that's willing to take a few notes. Thank you. Okay, so we have a note taker and we have a Jabber scribe, and I'm really quite grateful to you. This is our periodic meeting of the Human Rights Protocol Considerations Research Group, and we have the welcome and introductions, which I'm in the midst of at the moment. Then there's a talk by Jed Crandall of Arizona State University. Is Jed here? Oh, there you are. Thank you. And then there's a talk by Jan Matson of Ericsson. Is John here? Yes, you are. Thank you. And then we'll do updates on research group drafts, one on the association draft and one on the political draft. And the political draft has been sort of a topic of conversation on the list lately, so we'll try to continue from there. Then there's an update on the guidelines draft and short presentations from reviewers. And then finally, there's a discussion on consensus building and research group drafts. And this is for those of you that went to the IETF Open. This is a topic that's relatively consistent with that in terms of looking at what we do, though the question had come up on the list earlier of why do you act like an IETF group when you don't have to? So a little bit of conversation on that, and just to catch sort of the opinions of those of you in the room or remotely on that sort of behavior. So any issues, any questions about the agenda before moving on? There's the note well on intellectual property. And even though we don't need to follow IETF rules in terms of being a research group, we do in terms of privacy and code of conduct. Hopefully you've all had a chance to read it. One of the things that's important is also the goals of the IETF. And we focus on longer-term research issues related to the internet, while the parallel organization, the IETF, focuses on shorter-term issues of engineering and standards making. Of course, the terms longer and shorter are probably relatively relative. The IETF conducts research. It is not a standards development organization, and certainly this group has no intention of creating any standards, nor does anything we do approach a standard. While the IETF can publish information or experimental documents in the RFC series, its primary goal is to promote development of research collaboration and teamwork in exploring research issues related to internet protocols, applications, architecture, and technology, which I believe is what we are attempting to do. There is a primer. Okay, so we were chartered to research how protocols strengthen and/or threaten human rights as defined in the UDHR, and yes, and the ICCPR. So basically, that's what we look at. I'll go on with that. The objectives: to expose the relationship between protocols and human rights with a focus on the rights to freedom of expression and freedom of assembly. But early in our process, we started looking at other rights that may affect those, and given the notion that all rights are intertwined and it is impossible to separate any one from another, we have not strictly been saying, no, we cannot talk about that because it's not association. No, we cannot talk about that because it's expression. Basically, if they're related, we have. Although the documents we have been working on have largely related to those two. Then to propose guidelines to protect the internet as a human rights enabling environment in future protocol development in a manner similar to the work done for privacy considerations in RFC 6973, and we have a first attempt at that was with RFC 8280, and an ongoing work from that in the considerations document that we'll talk about towards the end of this session. And then finally, to increase the awareness in both human rights community and technical community on the importance of the technical workings of the internet and its impact on human rights. One of the things we need to look at a little bit more is we've been coming here to the technical community a lot. We have, and I know this explanation going through this was probably not planned, but I figured it was worth doing while reading it. I think we need to look at how to do more in the human rights community. They're starting to know about the effort. It gets discussed sometimes, it gets referenced, but we haven't had many meetings or sessions held in their venues. So it's something that we've been talking about, trying to find a way to increase doing. Okay, the outputs, we have internet drafts, policy and academic papers. Love to see more academic papers and policy papers. There is a film. There have been textual interviews, data analysis and visualization. There's been a certain amount of work done. And then protocol analysis, though that's one of the items in which we have reached caution that protocol analysis is all well and good of existing protocols, but we've been advised, I think that's the right word, advised to be more careful about doing protocol analysis of ongoing work so that we don't find ourselves interfering in any way with the engineering. Work to date, October 2014 to 15, we were a proposal, a research group proposed. In 15, there was the film Net of Rights at IETF 94. In 2015, we were chartered. In 2017, RFC 8280 was released. Current work, active internet drafts of the research group, freedom of association, which we will be talking about today. It is undergoing some rework, and we'll have a conversation on that rework, how it's going and where it needs to go. There's guidelines for human rights protocol considerations, which is ongoing work that stems out of 8280 and tries to capture the experiences and learnings of people who have used those guidelines to do protocol analysis. And notes on network standards and politics, that's a draft that is basically being considered whether it's ready for last call, our research group last call. I will be talking about some of the issues that have come up in discussions over the last months on the list related to that while we continue that discussion. What's next? That's it. So now we go to our first agenda item, which is the talk by Jed. And please come up. There's a red X. There's a clicker for you to change slides. And the blue sheets are passing around, so please make sure you find a chance to put your name on one. Hi, Jed. And how do we turn this off?
Okay. Clicker working. Okay. Is this microphone working? Okay.
Thank you for the introduction, and thank you for having me here today. So there's a famous quote from John Gilmore in Time magazine in 1993 that the internet views censorship as damage and routes around it. And so today I want to tell you about some research that we've done, looking at the lower layers of the protocol. So I'm talking about physical layer, link layer, and routing layer. So we know that in terms of internet censorship, there's definitely been a trend of growth, over the last 10, 15 or more years. But our question is, can you see that like in the AS graph of the internet? If you look down at the lowest layers of the internet and how the routing works, do you see the effects of censorship and internet balkanization down in those layers? So most of my co-authors and I started at UNM when this work started, and most of us have migrated to Arizona State University since. And same with me. So I'll join ASU's Biodesign Center for Biocomputation Security and Society in June. And the last time I took a biology class was in high school. So you might wonder, what business do I have in ASU's Biodesign Center? One of the things that we like to look at is evolution. And if you look at just the way the internet censorship has changed since 2007, when I started looking at internet measurement in this area. In 2007, the Great Firewall of China was basically a hack. It was like looking for packets, HTTP packets, and then doing a simple keyword search, not even a grep, just looking for a particular substring, and then not even a regular expression or anything, and then it would just reset both ends of the connection. And only about 3/4 of the paths into China were covered. And now almost every path into China is covered, and it's a very sophisticated system. It has active probing. It can detect VPNs. If it suspects something is like a Tor hidden server or a Tor relay, it'll connect to it and then see if it'll speak the Tor protocol. And they have a very sophisticated system set up. And just the way that things have evolved over time. So that's a big part of the center, is how things evolve over time. And that's one of the things we're going to look at today. And evolution of what? So we're going to define a measure called choke point potential. And it's going to be, we'll use choke point potential to define national choke point potential, which is a measure of a nation. And it's how easily they can choke off the internet with a few autonomous systems. And so on the left, we have an example of a nation with high choke point potential. The yellow nodes are AS nodes that are on the border, and they have connections to ASs outside the country. The red nodes are internal nodes. And so I'll talk about how we define it, but just intuitively, if you have high choke point potential, it's easy to choke off the internet with just a small number of autonomous systems. You can cover most of your border with just a small number. Whereas on the right, if you have a low choke point potential, then you connect out to the internet in a less restricted way, where it's hard without getting a bunch of autonomous systems involved to control the traffic coming across the borders. And there's a lot of different internet controls. We're going to focus on internet controls that happen at national borders. And just some examples of the kind of internet controls that we're looking for, because like I said, it's a very broad issue. We're specifically interested in things that happen at borders. So an example would be the internet shutdown in Cameroon, where somebody told me literally the army just cut a line with a machete, and then later after they fixed that, then they worked with the major ISP in the country, and they were able to keep the internet off for 240 days in a couple of different regions. Iran prefers to throttle the internet. They found that when you turn off the internet, people tend to take to the streets, but if you throttle the internet, they'll stay home. And then China has a lot of different sophisticated mechanisms that are all sitting probably in 3 big internet exchange points in Beijing, Guangzhou, and Shanghai, including the Great Firewall of China. And then there's things that arguably may or may not happen at national borders. So NSA has quantum insert, which is a lot like China's Great Cannon. So China's Great Firewall is doing deep packet inspection and then trying to reset connections. The Great Cannon can actually inject things like malicious JavaScript. And so NSA has something called quantum insert that does the same thing. And then there's been reports in Turkey of something similar that was used to serve spyware in Turkey and then adware to Egyptians and indirectly spyware also to Syria. So these are the kinds of things we're looking at is if you can do a man-in-the-middle attack, what kinds of things you can do. And if you're trying to do that at a national border, then you need a choke point. So we're looking at commanding heights of the internet. You know, where do you want to be sitting if you want to do these kinds of things? And this could be a company or a physical point of presence. So a company would be like an autonomous system. So, you know, you could call them on the phone and you could say, you know, assuming that you're a regime that wants to do this kind of thing, and national government, you call the autonomous system on the phone and you say, like, I want you to install these boxes. I want you to block this IP address for me. And then a choke point that's a company would be somebody you can call on the phone. Or it could be a physical point of presence. So you could say all of our internet has to come through this data center right here. And then you can do all of the censorship or whatever controls you want in the data center. Couple of things I want to mention. One is that IP layer censorship is often a prerequisite for higher layer censorship. So you might have heard about, like in various countries, there's social media filtering. And they'll even, delete posts after they've been posted. Facebook and Twitter do, censorship according to local laws in pretty much every country around the world. And then there's, applications that do censorship internal to the application. But you need, if you're going to really enforce this kind of thing, you need IP layer censorship to control what alternatives people can use. So I bring up China as an example a lot just because that's been the subject of a lot of my research. And in China, they use the Great Firewall of China mostly to stop people from using Twitter or Facebook, or to use VPNs and Tor to get out to Twitter and Facebook, so that when people use the domestic alternatives like WeChat and Weibo, then they can implement the censorship in the software and on the server. So that's just a long-winded way of saying, like, it's the censorship in the IP layer is important, even though it's a small piece of the big picture. And then I also just want to acknowledge that geography and virtualization come into play. So we're going to talk about choke points. You imagine an island nation that has only one cable out to the internet. That's a choke point, whether that island nation is a repressive regime or not. So geography is definitely consideration. And then you can also imagine virtualization. So you could have 3 different autonomous systems on that island that use that cable to make connections in the AS graph. And you can even go the other way, even just between 2 routers. It could be multiple actual physical lines that one connection is going over. So that's why we wanted to work at a higher level of abstraction, and that's why we're going to consider only BGP. So we're going to look at choke points just in the BGP graph and the autonomous system graph of the internet. And we could have considered trace routes. We could have combined trace routes with BGP. There's a whole research area about how to build graphs of the internet. And we could have considered physical maps like actual data centers and cable landing stations. But we found that BGP was a good level of abstraction to capture the salient trends. So if it's like a physical choke point like an island, that will be reflected in the autonomous system graph. Because BGP is basically an announcement to get to them, go through me. And in, somewhere like China where they have the 3 big internet exchange points and then lots of ISPs are forced to participate in that. And then one of those ISPs is in charge and actually coalesces all of the BGP advertisements. So you end up seeing that choke point in the BGP level too. And it's not going to be true of every form of choke point where you might do censorship that you'll see in the BGP graph, but it's going to be true of most. And that's why we chose that level of abstraction. So the research questions we're interested in is how are internet borders evolving over time? And so we're going to look at the AS graph and then how that's changing over time. And is there a relationship between internet freedom and topology? So we want to know, is there a correlation? If you're a regime that is, known to do internet controls, are you also likely to have internet that has a choke point in it? at the national border. So let's talk about internet topology. So we took the Chi to AS relationship data set. We built our graph in a pretty standard way. And this is a publicly available, it's inferred AS topology per month. And then we use the Team Kimru Whois service to determine the nation to node mapping. So every node on the AS graph, we want to assign a nation to it. And so just from the simple graph, you can already answer a simple question, which is, are internet borders getting stronger? So you can look at the ratio, the y-axis is ratio of autonomous systems that are border autonomous systems. So they're sitting at an international border. And then the x-axis is the date, and you can see over time it was almost a half, and now it's less than a third. So you can see just in this simple graph, the internet is getting a little bit more restrained as it crosses national borders. But we wanted to ask more sophisticated questions about specific countries. So we wanted to, dig a little more into detail. So we defined a measure called choke point potential. And I'm not going to explain the math because it's actually pretty simple. The idea is that you're counting the number of paths into the country and the choke point potential. Choke point potential is a property of an autonomous system, and specifically a border autonomous system. And you're just counting the number of paths into the country. And the choke point potential of an autonomous system is the fraction of paths into that country from the outside internet that go through that autonomous system. So here there's 4 paths into the country. F and E are outside the country. D is an internal node inside the country. And then A, B, and C are all border ASs. C has 2 of the 4 paths going through it, so its choke point potential is 0.5. Whereas A and B have just 1 path each going through them into the country. So their choke point potential is only 0.25. So if you can only call one of these autonomous systems and say we want you to block a particular website, you would call C first. So from choke point potential, you can define national choke point potential, which is now going to be a property of a country. And so we define the choke point potential of a country. You have to predefine some fraction f, and that's the number of paths that you want to be able to control. So if you want to do information controls, you want to block a website, you want to be able to say, well, I want 90% of the paths into my country to be covered. So you define f equals 0.9. So given that predefined f, the choke point potential of a country C, it's a reciprocal. So it's the reciprocal because we want higher choke point potential to be, what you would want if you want a few places to do the information controls. And that sum is just a way of saying, like, you'll call the autonomous system with the highest choke point potential first. So if you have an autonomous system that covers 2/3 of the routes, the BGP paths into your country, they're the first ones you're going to call, and then the second most next. And so you're just adding them up in descending order that way. And then you're trying to cover as many paths as possible. And the question is, how many autonomous systems do you have to call? What fraction of the border autonomous systems do you have to get on the phone with before you can cover that F ratio of paths into your country? So I'm going to give you some results, but just to put the results in context, let's just take a snapshot of the internet because we can compare across time and then we can compare across countries. So let's take a snapshot of China, around 2008-ish. This is a picture of China's internet put up by CNNIC. And again, I apologize for always picking on China. It's just been a subject of my research and a personal interest. And there's 4 lines of nodes in this graph. The top line is other countries. So those are the other countries that China connects to. The second and fourth lines are the same 6 ISPs. So each of the 6 major ISPs appears twice just to show how they connect to each other and how they connect to those 3 internet exchange points. And then the third line are the internet exchange points in Beijing, Guangzhou, and Shanghai. And so you can see there's a choke point at the internet exchange points. So if most of the country gets to the internet through these 6 ISPs, and then they're forced to talk to each other through these 3 internet exchange points, then you can imagine there's a nice choke point there. And then also in 2007, this was our first study measuring internet censorship. And in it, we said approximately 28.3% of the Chinese hosts that we tried to reach with basically an HTTP packet that said Falun Gong, which was one of the banned keywords. 28.3% of the time, it went along the path to the host without ever, being noticed by the Great Firewall of China. So the Great Firewall of China is basically covering 3/4 of the paths into the country at that time. Compare that, it's comparing oranges to apples a little bit, but if you read the recent literature about Chinese internet censorship, in various ways, it's about 1/2 to 1% now of paths that aren't covered. So they're covering a lot more paths now. So let's see if that bears out in our data. So let's go to 2009, which is as far back as the AS graph data that we have goes back. And you can see, let's check the time. So here the x-axis is the number of ASs that you have to control. And again, assuming that you call the one that covers the most paths first. And then the fraction of paths that you're able to intercept is the y-axis. And so, of course, as you call more autonomous systems, you can cover more paths. And then you can see, so there's about 6 ISPs that were part of this choke point in 2008-ish. All of this 2007, 2008, 2009, I'm calling it 2008-ish. Then, so if you look at 6 on the x-axis and you go up, it's about 0.8 paths that you're, 80% of the paths that you're able to cover. And again, it's oranges to apples because not all links carry the same amount of traffic, and, a path is not the same as a route. But, roughly we can see that there's a significant chunk of paths that aren't covered. And so let's compare that to China in 2018. Getting closer to today, you can see it's moved up and to the left, which means with just a few autonomous systems, China can cover well over 90% of the paths into the country. So you can actually see that evolution in the routing. And so you can compare across years. You can also compare across countries. So let's take a look at Russia in 2018. I can show you Russia in 2009. It's not that much different. And basically, you can see in Russia, they don't have a very high choke point potential like China. So it's very hard. They can call a few dozen autonomous systems. They're still not covering 80% of the paths into the country. So the graph is a lot more down and to the right. And so we can look at the evolution over time. United States, consistently has had pretty low choke point potential. It doesn't mean that they don't do horrible things on the internet, but in terms of the kind of controls that we're looking at, it would be very hard to do in a country with low choke point potential. You can see India and Egypt are up there a little bit, but you can see China for a long time was right around 0.1, 0.2, and then shot up just like we saw in the data. So they've actually taken steps through additional internet exchange points to make their internet have a stronger choke point. And you can see Russia has consistently had a pretty low choke point potential. And so as an application, we looked at the correlation between internet freedom and national choke point potential. So on the graph on the top, that's national choke point potential. So the countries that are white or light green are the lower choke point potential. So they have a harder time with a few autonomous systems controlling all the paths into the country. Whereas the darker green are the countries with the higher choke point potential. And then on the bottom, so we use Freedom on the Net scores from Freedom House. It's very subjective. They have free, partly free, and not free. And it's actually a score between 0 and 100. And so you can argue, well, is a country free if they really do surveillance or whatever? But in terms of the kinds of controls that we're looking at, which is specifically censorship and internet shutoffs and that kind of thing, it's a pretty relevant score to national choke point potential. So we wanted to look at the correlation. You can see visually that there's some correlation. And then if you're interested in the details, we have statistics in the paper to actually show that statistically significant. There is a correlation between the measure that we define, the national choke point potential, and the Freedom on the Net scores. But you might notice a huge outlier. Does anybody notice the huge outlier where there's not so much correlation? huge in a physical sense too. So you might notice that Russia is white, has a very low choke point potential, but it's red. It's considered not free in terms of freedom on the net scores. So that's an interesting case study. And ironically, one of my former graduate students, Royan Safi, she's now on the faculty at University of Michigan. And she has put out a paper last week saying that choke points aren't as relevant as they used to be because Russia is doing a great job at censorship and they don't have choke points. My own personal opinion, I don't think that they're going to reach the level of sophistication that a country like China has or Iran. They do, some very sophisticated things that we can talk about offline, my reasons for thinking this, but I don't think that I think that choke points are still relevant because anybody can just go to a bunch of ISPs and say, all of the dozens of ISPs that are border ISPs in our country, just have them throw this HTTP filtering box in path. But that, it's a lot harder when you try to do the more sophisticated things, in my opinion. So that's one thing I want to tell you about is just the research that we did. But we also have some data and tools I want to tell you about because I'm hoping that, you have your own questions and your own thoughts about what might be reflected in the AS graph. And you can use our data and tools. So in terms of our data techniques, so we took the KIDA data and then the AS relationship data set. And then we used a breadth-first search algorithm and the Gao-Rexford routing model to identify paths between AS pairs. And then the part that requires a supercomputer is generating the routing trees for each destination autonomous system. So that way you can reason about the routing from one autonomous system to another for any pair of autonomous systems in the world. And we saved those routing trees. So if you want to use our tools, you don't need a supercomputer. Just download the routing trees from us. And then we calculated choke point potential for each border autonomous system. But once you have that graph, you can answer any question or make up any measure that you think would be interesting. And so we have all of our tools are open source and they're bundled up in this thing called BGP simulation analysis and storage. And then we have the routing data. So if you don't have a supercomputer handy, you can just download this. It's 200 gigs compressed and then it uncompresses to about 2 terabytes. So I'm sure you'll be able to find my slides on IETF or just Google my name. And then that way you don't have to write down these other 2 links. So the second link, the middle link, is what I just talked about, the routing trees and all of our software and everything. As of yesterday, it was under maintenance, so hopefully it'll be back up soon. I'll email the student that's running that. And there's also the Internet World Map, which is a tool you can play with them. I'm about to show you. So just for fun, I went to the Internet World Map. This is something that Curtis, the first author of the paper, did, where you can actually draw the autonomous system graph for each country, and then it does border nodes as yellow, and then internal is green, and foreign is orange. And you can see how Singapore has changed from 2015 to 2018. It might not be, maybe on this slide, it's big enough to see there's a yellow, there's a very substantial border autonomous system in 2015. And then fast forward to 2018 and it's more spread out. There's a lot more border autonomous systems connecting outside the country now. So we would expect Singapore's national choke point potential to have gone down between 2015 and 2018. That's exactly what we see. The yellow line that kind of goes up after 2013 and then back down after 2016 is Singapore. And you can actually see their national choke point potential went up for a while and then came back down. And a lot of times these things happen because of, internet exchange points and, different changes that get made. And then I just took some of the countries in the region. So you can play with it, go to that website. You can put in your own countries to play around with. I put China for context. You can see China going up. And I just selected a bunch of African countries. And you can see there's kind of a downward trend. So as they get more connected to the internet, they have lower choke point potential. The one exception is Ethiopia. Up there at the top, there's just a line that's 1.0 all the way along. And that's to be expected. So if you take a look at the internet of Ethiopia, it's one autonomous system, which is a border autonomous system, and then it connects to 3 autonomous systems outside the country. So that's why their choke point potential is 1. So in terms of takeaway messages, so hopefully I've convinced you the national choke point potential is a useful measure and something that's useful to think about. But I also wanted to tell you we have code and data. So if you have your own questions, your own measures, your own, things that you want to do with it, please get in touch with us if you have any problems with our tools or data or anything. And in terms of future work, so Stephanie and Curtis are interested in missing links. So they're working with a graph theory expert and trying to identify the links in our graph that might be missing using statistics. I'm more interested in physical infrastructure. So if there's blackouts, how do you measure the internet from inside a blackout, see what's going on? And then TCP/IP oddity. So if you're interested in details, I'll just give you a little preview. So initial sequence numbers, we looked at TCP initial sequence numbers. It's something like 13% of the internet generates initial sequence numbers in a way, and this isn't SYN cookies, ignore SYN cookies. It's still 13% of the internet generates initial sequence numbers in a way that lowers the entropy and makes it easy to hijack connections. IPID, similar problem. There's a third of the internet is generating IPIDs in a way that is vulnerable. So if you're interested in that kind of low-level TCP/IP stuff, please talk to me offline. And with that, I'll just acknowledge my authors so you have their contact information when you find the slides, and I'll take any questions.
Thank you. That was really quite fascinating. One of the things you mentioned, and anybody, I'll ask my question while lining up. You mentioned Iran once. At the moment, we've got, it basically in a shutdown where the news reports that only 5% of traffic is getting out. Now, I don't know how they figured out that kind of measure, but have you guys looked at those kinds of measures and see how they relate to your choke point research? And have you actually, you didn't have any pictures of Iran, which would have been very topical, but I was wondering if you've done that analysis too.
So we did a lot of different things with the statistics, and then just because of the vagaries of academia, a lot of it got cut from the paper. Now the statistics section is like half of a column. But mostly we compared things like freedom on the net scores, and there's another one like freedom of the press and different indices, and then we compared them to different ways of doing our measure. And then in terms of statistics, if you look at lots of different things, then you have to account for that when you say something is statistically significant, because you don't want to look at 20 things and say, oh, look, it's statistically significant. When you look at 20 things, it's not statistically significant anymore. So we accounted for all of that. I'm not the statistician. The statistician has actually been on the paper. But we did a lot of controls and things. So we tried to control for a lot of the things in the CIA World Factbook that might explain the correlation, to make sure that we're not just saying, well, poor countries are poor and rich countries are rich. And so the statistics stood up to all of that, but all of that had to get cut out of the paper. But we did not, and this would be interesting to do, is, look at some of the data that Tor has, or UNI, or, whoever is able to come up with these numbers, like 5% of the traffic, and try to correlate to that. So that'd be something interesting that if we don't have time to do, hopefully somebody will.
Okay, thank you. There's three of you at the mics now, and since we're already running a little late, I'll go with the thing, but I think you were first. No, she was first.
Oh,
whoever was first, please
Sure.
go first.
Yeah. Okay, Nalini Elkins. There's a country that I'm pretty familiar with that's had internet shutdowns, two in the last few months. And also, it's an interesting thing. I'm pretty sure what they did was just call the ISPs and tell them to shut off a particular region. They're a lot more concerned about particular, like pinpointed targeting of certain regions rather than things coming across the border. I think it'd be an interesting thing to know ISP coverage, because if there's like one ISP serving a particular region versus, like, I know there's a lot of projects like, the Google Loon and various other kinds of things that might in the future give us a different, the inability to do anything like this, governments to do that. But who knows what, I mean, it's just a curious, I'd be interested to know something like that. Whether you have distribution. Also, that particular country I know too, again, from word on the street, they have a very sophisticated fake news ability.
So I missed the name of the country.
What's it?
Which country was it?
Yeah, I'm not wanting to say that.
Oh, I'm sorry. Okay.
Yeah. But I mean, as I say, it's just something Again, I don't want to say it because I don't have actual hard, cold facts to know that's true. I'm just saying word on the street. Yeah. So I'm just curious as to your thoughts on some of that.
Yeah, I mean, there's definitely a lot of issues, and depending on whether you want to look at Western countries or other countries, what kinds of issues you might look at would vary. And so we looked at these national choke points, but it's becoming more and more relevant, the regional issues. So especially in India, there's internet shutdowns just constantly in India and its specific regions. And then there's countries like Brazil and Germany. Their concern is more like, if we're routing data within our country and we don't want the NSA spying on us, how can we make sure that our data doesn't cross an international border and then come back in? And so those are two, separate questions that you might look at in the AS graph, but those are not the question we chose to look at. But they're definitely interesting questions that we should look at. So.
John Brewer, Independent. There's been a proliferation of IX extension services where internet exchanges will allow you to connect to the IX remotely. So, for example, you could be within a quite restrictive country. You could have a circuit from the very restrictive licensed national carrier, and you could just run a tunnel over it and appear to be peering at, say, BBIX in Japan or Hong Kong Internet Exchange. This creates a lot of adjacencies that really are still going through one choke point that you haven't mapped. I don't think you've mapped in this. Have you thought about this problem and how extensive it is?
So it creates an adjacency because of the internet exchange point?
So it allows an ASN inside of a restrictive country to tunnel out and create a lot of adjacencies that make it look like an ISP inside of a restrictive country is actually peered with 200 ASs in another country. However, they're still going through the choke point of their national carrier, which can shut them off like that.
Yeah, that's interesting because it would that would shift the choke point to the internet exchange point in terms of our data. Like we would see the choke point as the internet exchange point and not as the physical infrastructure. So yeah, I think we chose that level of abstraction of BGP just to kind of get a handle on the problem, be able to look at trends over time. And it's pretty hard to get physical data. So definitely physical things matter and the physical infrastructure matters. It's harder to get data, and it's especially harder to get data over time. So if anybody has recommendations like how we could find that data, that would be really interesting to us. And we also just in terms of physical infrastructure, you get, and this speaks to the first question too, is you get regions like, Tibet, where there'll be very local shutdowns, and then they'll get very conflicting information about where the internet is shut down or whatever. And so they would like a map of their local little internet, like, what goes on, down here. And we haven't really mapped that, kind of physical infrastructure. Like if you turn off this cell phone tower, who actually gets cut off? We've only looked at the AS graph so far. So.
Thanks. Very interesting work. You had a note on one of the slides there about thinking about VPNs and how that might affect traffic. Can you speak to what your thoughts are as to what kind of, if you imagine a world where much more traffic is encrypted, maybe using encrypted SNI so you can't kind of block that way, how would that impact on what statistics you might use instead of the ones you have? Or how would you evolve your current statistics in that kind of context?
Yeah, I think in terms of encryption, I mean, it's hard because if you look at the way the internet censorship gets applied, especially in the countries that are good at it, it's a very graduated response. So as long as they can tell that you're using a VPN, they can be very successful just watching VPNs and then shutting them down when they really need to, and not exerting a lot of pressure for there to be, a lot more obfuscation added or anything like that. It would be great if there was, obfuscation encryption that convincingly could stop these kinds of internet controls. But I think the reality is, like, VPNs are a good example. A lot of times, there'll be VPNs that work inside a country, and the only reason they work is because the VPN company you're connecting to is sharing the data with that country's government. So.
Hi, Joe Hall. This is wonderful work. Thank you for doing it. choke points is obviously a rough metric. I mean, I'm not trying to criticize you. It's great stuff. I'm wondering, there's so many other things that powerful sensors do. Have you thought about extending this to measuring not just choke points, but some notion of instrumentation? Like, for example, the Great Cannon, which may not be as interesting as it was when we first saw it come in, which injects into HTTP flows JavaScript and DDoS other sites, right? It might be interesting to sort of be able to look at some of these things like the graphs and stuff with not just the ability to sort of shut stuff off, but the ability to tinker with flows in ways that might not be shutting down, but bandwidth restrictions or the probability of getting a TCP reset or something like that. That may be too hard to analyze like this, but I'm just wondering if you thought about extending it to stuff that's not just choky, but things that are kind of tinkery.
Yeah, I mean, that would definitely be interesting. And I didn't really have a related works slide, but there have been other studies, and we cite them in the paper, that look at, we were interested in the AS graph, but there's been other studies that have looked at, who controls all the paths for DNS, and, just assuming they actually had usage statistics for everybody over the world. Are they using Google? Are they using Facebook? Are they using something else? And they actually considered all of those paths and where your DNS is going and everything. And they got some pretty interesting results that are complementary to ours. So I would encourage, that's another paper from my former student, Rowan Safi. I'd encourage you to check out all her work, read all her papers. So
Thank you very much. I think it was great, but thank you. Okay. Call up John Mattson. I want to explain that we're running a little late, but this is really worthwhile, and I'm not going to try and cut you at all, but we'll have to hurry on some of the stuff later. So please go ahead. Thank you.
Yep. Thank you. So this is about 5G security, and in particular how 5G security affects privacy and surveillance. So 5G is getting deployed now, and we have noticed that there is a lot of interest both from government organizations and also from privacy, democracy, and human rights groups how 5G will affect privacy and surveillance. So 5G it's faster, more flexible, more efficient, and it's also more secure. So this was Ericsson's goals for 5G. Cannot talk for other companies' goals, but I think there are quite a lot of alignment. There's new stronger authentication. There's a zero trust architecture inside the networks and between them. Talk more about that and authentication. There's more separation, different signaling. There's encryption and integrity protection of basically everything. At least that was the goal. In many cases, integrity protection was a bigger problem than lack of encryption. You could inject traffic and get data out. And a main goal that has been mainly driving by Ericsson is to prevent tracking and identification of users. And the main standardization organization for 5G is 3GPP, but this is also done in a lot of other SDOs, particularly 5G uses IETF standards to large extent. And trying to go through three things, which I think is mostly interesting for Hrpc. Very much hope that you have questions. Happy to explain. So one security weakness in cellular system had traditionally been the interconnect systems between operators. That one is behind. Okay, good. So here is a different media coverage of attacks on the interconnect systems. So the protocol used traditional for the interconnect system is called SS7. It was designed in 1975. It's a product of the time. It uses no cryptography at all. And there has been a lot of attacks using that lack of cryptography. There's also been examples of SS7 interface being accessible from the internet. In 4G, this was replaced by diameter. There's an evolution of radius. It has cryptography, but there's attacks on diameter where you can downgrade it to SS7. I don't think just as vulnerable is correct, but there are vulnerabilities. So 5G completely redesigns the interconnect interface. So this picture shows the interconnect here called N32, technical name, between the two different operators. And connection between two different operators can be you make a call from the US to Europe, or you go on vacation somewhere and the visited operators has to talk to your home operator. And this new interconnect system is it's using a TLS tunnel to set up a shared key, and then that shared key is used to encrypt and integrity protect as much information as possible. Previously, in between here, there can be one or many interconnect providers. And in 5G, they are given information on a need-to-know basis, so as little as possible. And any modifications by them are logged and signed, so you can see who changed what. And this system uses Jose and OAuth and TLS 103. Inside the networks, there's a mandatory requirement to support TLS 103 by all nodes. And when turned on, all the control signal inside the network would be protected. So in case of some attacks or breach, it's much harder to get information or to escalate any attacks. Main focus on 5G is to completely eliminate all false base stations and IMSI catchers. This is also something that has raised a lot of interest. So what is IMSI catcher as a false base station? There's quite many forms. Here are some examples that got into media. 2013, there was IMSI catchers in trash cans in London. So basically, these IMSI catchers, they catch the permanent identifier of your phone, and then they use that to track you and to sell advertisement. Another example is more full base stations. In 2014, there was media reporting on a lot of false base stations placed out across the USA, near military areas, for example. I have not seen any follow-up what happens to this, but so these are typically more capable base stations being able to make you connect to them and record everything. And after this, I had a call with the FCC that was very worried and wanted to understand what could be done to mitigate this in the future. And a very recent example from just a few months ago, there was media reports that there was a lot of false base stations in the White House. And I think in London it's clear who put this out. In the other cases, of course, nobody is taking responsibility for this. And typically you get this media reporting, then you don't know so much else. So IMSI catcher base stations, they go under a lot of different names. In the US, they typically go on the name Stingray, and this is a brand name from some company. As far as I know, none of the companies actually making mobile equipment makes this type of equipment. So these are different companies. having nothing to do with 3GPP. And there is, in general, you can say that there's two different kinds of base stations. There are fake base stations that can completely mimic all the function of a cellular system. And these only work in 2G, so the oldest system that was starting to get deployed in the 1990s. It was mitigated with 3G that introduced network authentication. But the problem is that 2G is still here in large part of the world. Some parts of the world has completely shut down 2G, but you still have the problem that, for example, the US has completely shut down 2G, but US phones will still happily connect to a false 2G base station that says it comes from France or Vietnam or China or any other country. Then the mobile thinks it's roaming. Then there are more lightweight false base stations like the one in the trash cans. The simplest way would be to just passively listen to the permanent identifiers on the radio, but this is quite inefficient. So typically these false IMSI catchers are active, so they tell the UE to tell me your permanent identifier, pretending to be the network, and the network answers. And typically these false base stations, they use a lot of techniques to get phones to connect to them. Can be to use a very strong signal strength. Then they actively send different messages, both using things in the standard, but also hacks on different phone models or undocumented thing in different phone models. And they try to get the phones to connect to them, and then they typically try to get the phones to stay there as long as possible. 5G has really set us a goal to completely eliminate false base station. And the 5G standard incorporates a lot of different techniques to do so. The permanent identifier, which often is an IMSI, is encrypted. Then there is a strict refreshment of the temporary identities. 3GPP system has had temporary identities since 2G, but there was no strict rules on refreshment or how they were generated. In 5G, they are forced to be random looking, and there's strict rules on refreshment. Then the permanent ID is not used in paging anymore when the base station in ASCII trying to figure out where the UE is. There is integrity protection of user plane traffic, or some attack being used there. Radio direction are now secure. So typically false base station, if you're connected to 4G, the false base station will pretend to be a 4G network and tell you, you should connect to this 2G network instead. That will be better for you. And that was not protected. In 5G, it is protected. So if you're connected to 5G, a false base station will not get you to reconnect easily. Of course, it can jam the 5G frequencies altogether. That's very little to do about that. And then there is false base station detection using both UIs and networks in collaboration. And typically using the data available in the network, it's very easy to see that there has been false base station. Typically you cannot shut them down remotely, but you can send someone out or report to the police. The most important technical advancement is the encryption of permanent identities. And when this is enabled, the permanent identifier, typically called IMSI, is never sent in the air. Encryption is done. Here is the home network. So the public key of the home network is stored on the SIM card. Then it's encrypted using the CFRG curve 25519. And so in 5G, the permanent identifier is called SUPI. It is often an IMSI. The encrypted SUPI is called a SUSI. And if this is enabled, the permanent identifier will never ever be seen. And if you know how encrypted SNI work, this works exactly the same or very similar. And both of these parts I talked about is already, since several years ago, already standardized in 5G, in the 5G standard, the first. Another surveillance-related topic that is not in the 5G standard yet, but we hope to get in the next release, is to limit the impact of compromised long-term keys. And this was in the Snowden revelations. It was reported that Gemalto, SIM card manufacturer, had been hacked, and that the hackers had stolen a large amount of long-term keys. After that, Gemalto has acknowledged that they were a hack, but they have not been very open about how many. So we don't really know how many keys were stolen and how it happened or so on. But we can assume that whoever stole this key intended to use them. But we don't know if it was for specific attacks or if it was for more mass surveillance. And compromised long-term key is not specific to symmetric keys. We have, for example, Heartbleed a couple of years ago that extracted private keys from asymmetric. Unfortunately, there is good method to try to stop this. So in cellular networks, the authentication is based on a symmetric key. One part is stored on the SIM card securely, very hard to extract. The other is securely stored in the home network, also very hard to extract. But what these hackers apparently rumoredly did was to get hold of the key before it was delivered to the home network. And so what can you do if you get this key? You can do active attacks, so you can authenticate as the network to the UE, or you can authenticate as the UE to the network, or you can do both at the same time, being a man in the middle. That's hard to do at a large scale. It's relatively expensive, and you can be detected. You can also do passive attacks where you just eavesdrop on information sent over the air, and then you can decrypt everything. This is much easier to do at large scale. It's relatively inexpensive, and the risk of being detected is very low. And with this, as the system is designed in 4G and earlier, you can also do this. If you recorded information in the past and then you get the long-term keys, you can decrypt the past information. So how do we stop this? This is quite straightforward. Known techniques. You do a ephemeral Diffie-Hellman, send G to the X, C to the Y, and then you calculate G to the XY. And this we are now working to introduce in the EAP, aka, so 5G, previous 5G used their own mechanism for authentication. In 5G, it was introduced that you can always use EAP. So for access to the mobile network, you can use EAP AKA, which is the SIM card-based authentication method. For private network like industries and so on, you can use any EAP method. And EAP is an IETF standard. For example, EAP TLS. And we are now working, EAP TLS, it already has Diffie-Hellman key exchanged with perfect formal secrecy. We are now working actively to introduce that into the SIM card authentication. And this is has just been working group adopted here in the IETF, in the EMU working group. And there is a study in 3GPP to what if this should be introduced in 3GPP and what other enhancement should be done. But if this is done, then the attacker is forced to do active attacks. You cannot decrypt information in the past, and you cannot attack future communication if you're passive. There's a lot of questions.
Please, any questions at the microphones? Mm-hmm. I do not see any. Okay.
I'll ask one. This is Bernie Volz. In one of the slides, you said that the SUPI, S-U-P-I, was shared with the roaming network. Is that a good idea? I mean, I understand it's probably the least sort of, potential exploit, but it opens the opportunity that if somebody, if you roam somewhere, somebody breaks into that remote network, that operator's thing, they can get your SUPI.
Yeah, I think nothing is perfect. So yes, right. The roaming network will have your SUPI. But and I think it has to have it for technical reasons, at least for now. Change from 4G to 5G is that the roaming network only gets the SUPI if the mobile actually is there. There was attacks on 4G where a ROG roaming network could get authentication vector even if the mobile phone was not there. 5G forces the mobile phone to be there at least. You need to be physically there in that network.
Okay, I agree. It's it's probably the lowest issue because protecting it further out on the network is more important. But it's just kind of curious as to why they didn't also protect that. Thank you.
Next, please.
Hi, Mohit. So I have a question about this interconnect security. You did mention that now it's using TLS and certificates, which is a big improvement from SS7 and diameter. But I still wonder, do you just trust anyone that has a certificate, or do you still have to manually configure that I trust certificates with these domains in the SN?
Yeah, currently certificate distribution is not specified and out of scope. It's up to the operator. So, but there is ongoing study how to make this more automatic. But how it will look like, I don't know. It will not be the internet PKI.
Hi, Elliot here. John, thanks for your presentation. As always, a really good job. On that last point, obviously, we've been doing a lot of work on how we address here at the IETF about how we actually do trust establishment between parties that are not necessarily known to each other. And so some of the animal work is probably worth looking at. My question, though, is you were talking a lot about how 5G works to avoid the problem of false base stations, if you will, false cells, right? So pulling this back to Hrpc in terms of sort of the focus on government, one of the questions might be how this would interact in terms of, from a pervasive surveillance standpoint, what the governments would need to do, because those are the ones who employ some of the technologies. So it might be worth maybe follow-up work to talk about what 5G means in terms of how they'll be using or what they'll need to change, and how that might be looked at from perspective of somebody who doesn't want to see that practice continued.
Thank you. I want to make one point about people talking at the mic. You keep trailing off because I think you're too far from it. Did you manage to hear all of his question?
I don't know if there was a question. It was a note to Hrpc to follow this up, I think.
Unless you have a comment on it yourself.
Don't know. I think there's different actors here. There's private companies using these type of things to sell advertisement. Then there's nation states using false base stations in other states. I think that the attack states definitely want to stop that. FCC is, for example, worried about this. Then there is a report about police using IMSI catchers. But the 3GPP system was not designed to allow any of these. So all of these will be mitigated.
Right. So I think some of this has to do with the trust model from the base station to the device. Some of it has to do with who is an authorized base station, if you will, within a provider network, and what sort and how the governments might influence that. So I think there's probably some thought that could be given there.
Yeah, I think there might be new LI solution introduced in the future when this path is cut off. But then it will be hopefully authorized by a court and will be logged.
I'm Mr. Bertolo, Open Exchange. Now, since this is a discussion that's coming up in other environments, I'm curious, how do you do the legal interception part in this, since this is still a requirement in most countries? So, I mean, this is end-to-end encryption only on the radio part, let's say, or maybe up to the home network, but then there is a point in which the communication is anyway decrypted, and so it can be also shared with third parties. Or so, am I getting this right?
Yeah, if you ask about legal intercept, so I think 5G will not change that very much. You can do LI at both in the visited network and home network. It's should be authorized, should be logged. If it always is hard to answer in all countries, Ericsson has a policy to not participate in any mass surveillance. It should be authorized, hopefully by a court order. Yeah.
Gushavat Grover, Center for Internet and Society. I think following up from Elliot's comments, first a question about the encryption of the permanent identifier. I noticed you mentioned if it is enabled, and this is a problem like I personally face while reading 5G specifications, which is what options are actually left to the operator, and what are parts of the standard itself which have to be mandatorily followed. Is this part an option left to the operator, or?
Yes. So encryption of the SUPI it's mandatory to support by all equipment. So support will be there. It needs to be enabled by the operator. The operator as organization GSMA has said that this is highly recommended for the operators to turn on. So I would believe that in the Western world this will be turned on. I don't think it's turned on in the very first 5G deployment that we are seeing that have been deployed now. It's probably something that will start getting deployed next year, but I don't have any data on that.
And is this detectable by the user equipment?
Detectable.
As in whether the permanent identifier is encrypted.
The UI, of course, the UI knows if it's encrypted, the permanent identifier. It's probably not visible to the end user, but it's very visible for the radio traffic. So I think this is something that academia can. Probably the operator will tell you if they encrypt this or not, but you can also quite easily check on the radio if it is encrypted. If it's not encrypted, you get the same IMSI all the time. If it's encrypted, you get some random string.
As in the operator does have control at a particular moment to enable or disable it.
They need to enable it, yes.
Okay. And a question about how the interconnection encryption would work. So if there are, if I am going through another network to reach the final destination network that I need to connect to, so the actual encryption is just between the two. So A, B, C, and I'm connecting through B to C. B, I don't see the larger point of such encryption because B can still decrypt it, the traffic, right?
Yeah, so the roaming, if you are roaming to another country, that other network will see your permanent identifier eventually. The encryption of the permanent identifier it's end-to-end, but then it goes back to the roaming operator. The main reason to have this encryption is not to hide it for the roaming operator, it's to hide it over the air.
Yeah, my question was about intermediate networks that essentially if there's a hop that you need to get through to reach your the destination network. Not in this map, I suppose, but if that's how
there can be some transit networks in between here. Is that what your question was about?
Yeah.
They will not see it during this handshake. Whether they have access later, I cannot answer. If I don't know.
Okay.
Yeah.
Thanks.
If it's visible in any of that communication.
And lastly.
Hi, Nalini Elkins. So now I'm thinking if that I'm a very intrusive government that wants to surveil everybody, and I want to have the power. So one thing, I'm going to probably look for the weakest point. And so if you make all this secure, then I'm going to start attacking, and I'm going to go on to the client. But the other thing, I know there's been a lot of talk, and whether it's true or not, I don't know, about if you can get the not false base station, but the device itself, the real station, and then I, as the the surveilling government, a la Gemalto, I hack into it or I make that insecure so that on the back end, it's given me all the information that it needs. So I don't know what the answer is, whether like an independent body which looks at all these things and kind of says this thing is doing this kind of stuff, this thing is not. I don't know. You know what I'm saying?
Yeah, there are certification programs for the security of all these type of nodes. I think the base stations are quite closed. I don't think it's easy to break into a base station, but I don't know. Very much data is, of course, available at the operator. Basically, the mobile network needs to keep track of all the users. Ericsson's equipment is not designed to you're not supposed to try to stop you from extract large amount of data, but it's probably still possible. Yeah.
I had closed because we're already 15 minutes over.
Okay.
But
Do you, quick.
okay, it's really, really closed after him.
Okay. Sorry, Mohit. So, do you have transitive roaming agreements? So, if I'm roaming in Singapore, will there be only like roaming agreement with some operator in Singapore and my home country, or do you think there will be hops in between?
There will very likely be hops in between. It depends on, but it probably depends on the actual operator. And there might be a direct link between the two operators, but there might also be several transit operators in between. Typically, they do different type of processing. Yeah.
Thank you very much. And thanks to both of our speakers here, and an invitation to others of you that are researching things, especially things related to human rights protocol considerations. Please let us know for future meetings. Now, I guess it's Joe Hall. I guess Stefan is also online, but please. And the clicker is there. A quick clicker? Quickly. 15, but as complete as you need to be.
All right. Hey, everybody. This is an update on draft association that I and Stefan Couture took editorial roles over 2 IETFs ago, I believe. So to give you some quick background, this is one of the specific drill down rights drafts after 8280. We had aimed to have a new version, but both Stefan and I got new jobs, and it got really complicated, and we haven't done a whole lot other than what you're about to see right here. But what we started to realize over the past month working on this is that we really need to have more discussions about this, especially, and I want to sort of note for Niels and Gazella that the proposals we'll make at the end of this are sort of a refactoring of the entire draft. And so that's a pretty substantial change, and we don't want to do that without some significant discussion of the research group and with the original authors. And we'll propose a way forward. So a summary of the draft as it exists right now, the research question is, how does the architecture of the internet enable and or inhibit the right to freedom of assembly and association? The methodology was to test the causal relationship of protocols in terms of their effects on association and assembly through typical and paradigmatic cases. We have since then taken the word causal out of all of this because we have a lot of academic critiques about causal relationships. And there's 7 protocol cases in the document, and we sort of are wondering why these particular cases. So 3 issues I'll tee up for discussion right now. What is the aim of the draft? Why these cases and not others? And we're going to talk about protocol cases versus cases around specific things that happen in the real world and how protocols affect those things, and then talk a little bit about the literature review and how that may need some enhancement. So first, the aim of the document. There's sort of 2 stated goals in the document. The first is that the document seeks to deepen the relationship between internet architecture, protocols, and standards without creating any new guidelines. This is the HRPC, Human Rights Protocols Considerations. Why is the goal not to do something about, why is human rights not in the goal right there? And why are we not creating new guidelines? I bet I have some ideas about why we're not creating new guidelines given the relationship between IRTF and IETF. And the second goal is to test the relationship between protocols and associations. But what does it mean to test? The draft doesn't really talk about that much. And are we at all interested in the relationship with association or the broader right, as sort of treaties and other people recognize this right as being as assembly and association? Are those things different? They probably are. And then, importantly, how is this document going to be helpful for folks working in the IETF if they want to see this as research input into things they're doing? You know, how does that work at all? The second issue is the cases. So the cases that we have in the document right now are conversing, peer-to-peer, and then grouping together, getting into groups. And so in the conversing sense, there's IRC, there's mailing lists, there's WebRTC. And if I'm talking too fast, just raise your hand and let me know, and I'll slow down. In peer-to-peer, there's actual peer-to-peer technologies, and then there's version control technologies. And then in grouping together, there's things like the domain name system, autonomous systems. But it's unclear to us why these particular cases are chosen. The document sort of says, without explanation, that they're typical and paradigmatic, but that's not really explained in the document. But if we were going to change these cases or think about a more coherent way of talking about cases at all, what would we do? Might we think about events that happened, sort of socially things that happened in the world and how protocols may have affected those kinds of events, either specific ones or over periods of time, like shutdowns, which is sort of a genre of things that happen in the real world. And then being former academics, the literature review is something we think we really need to beef up and spend some time digging into. We really think we need to be more systematic and explicit about the universe of definitions of the right to freedom of assembly and association. There's a lot of material out there. What are the boundaries of those rights? You know, how do we actually think about those? You know, how have people thought about the boundaries of these rights? And then, do we need to better distinguish between enabling the capacity to associate and assemble the positive right and disabling it in the negative sense? So to what extent can you exclude folks from particular types of associations or assemblies? That's also part of the right. It's important, you know, to have a group that you're confident in, that you can kick people out of the group. That may be a little different for IETF, but and the right to exit. There's a link in the document that's actually broken. There's a %23 that should be a pound. So if you click on that and you get an error, just change it to pound. I don't know how that happened. It must be Google Slides. And then we're actually looking for other examples of folks who have thought deeply about the right to assembly and association specific in digital technologies. And there's a few things that we think are out there, know they're out there, that we just need time to find. This is something that we haven't shown before. This is a potential refactoring of this document that we think might make sense. But we haven't done any of this because we really want to talk through this and make sure that folks like Niels and Gazella think that this is not a bad way to restructure this. And you can see, you know, there's a pretty deep literature review in here that sort of sets up the boundaries of sort of what we think about the right. And then we actually go into maybe a different set of cases around events or socially things that happen in the real world and how protocols might affect that, rather than looking at the protocols as these sort of clinical things themselves. Now, to do this, we need help. Obviously, we need help. We really want to make this draft. We want to make the draft in a collaborative fashion. We want to actually write it in a collaborative fashion. So we're thinking of having 3 short seminars, to like working seminars. I guess you could call them an interim. I heard someone say that the other day. I won't say who, but we could think about these as short interim meetings for Hrpc between now and the March Vancouver meeting that will allow us to work in a group on these kinds of things and get a more clear idea of folks who want to participate and contribute to this, of where it should go before, you know, publishing a new version of the draft and sending it back to the group. There may be a few versions along the way, as a matter of fact. Anyway, that's it. I spoke very, very fast, but I'm wondering what people think. Are you in? Do you think this is crap? Let me know.
Thank you. One of the things I want to say is an interim or something by any other name by mid-December may be challenging.
Yeah.
But I think the idea is great. I'm just looking at mid-December and getting it set up and announcing it and making it happen. That's tough.
Yeah.
I mean, my point is that there are 3. So maybe not everybody can make all 3. Maybe they are a bit redundant, but I'm sure you can continue to nudge the needle with 3. And I think it's a good proposal to do it that way, actually.
And now we have 3 comments, at least.
Hi, it's Elliot again. Joe, I really like your approach in terms of the rigor that you're introducing. I think that's very useful. 2 points. First, on the question that you asked about whether the document should provide advice to the IETF community, the IRTF is certainly not prescribed from doing so, and I think that's part of the charter of the IRTF, is to provide that, assuming you can derive useful advice from the the experience of having putting together the document.
We will see.
Yeah, it's surely an open question. The second point, though, is in terms of the examples. So we have standards examples, and certainly DNS as a rendezvous mechanism can be used to impede freedom of association. One can pretty easily envision that. The thing that I was thinking about, though, is the societal discussion that we're having about this is well outside the protocol arena right now. It's what sort of impact can governments have on social networks like Facebook and Twitter in this regard. And so one of the things I would like you to leave open, and I think this group should leave open, is the import of this work compared to the what's going on elsewhere. If it's really minor import and it's going to be a really major effort to try and put this together, let's be honest with ourselves about that. And I leave it as an open question, but I think it should be a question.
So let me restate just a little bit of that. You're talking about a lot of the efforts to control this stuff is aimed at platforms, not necessarily technical protocols. Cool.
Yes, exactly.
Okay.
And it could be that we might want to refactor again towards that. It's a little less in the towards the IETF space, perhaps, but it's still a very valid area, and it could be that maybe it's a valid area for others to do, but I'll leave that open as well. But I think we should have that discussion.
Cool.
It looks like Stefan wants to comment. So since he's one of the authors, I'm going to give him a chance to respond before going to the rest of the queue.
I love the red button.
I think you're on.
You may have to click something, Stefan, or you may be muted. This says you're speaking.
I think the chairs have to hit a button.
We hit the button.
We did.
Oh, no.
And now he went away.
Oh, did we kick him out?
Don't hit the button twice.
It's like literally Pac-Man,
I
right?
think he just has to go back.
Okay, please go ahead while we're waiting for Stefan. Stefan, please put yourself back in the queue, and maybe we'll get it right this time.
Mr. Yaskin.
So this is Jeffrey Yaskin. Sorry if I just missed this in your slide. I'd appreciate seeing some discussion of the interaction of parental and enterprise filtering with the freedom of association.
Cool.
Okay,
that
please.
Definitely wasn't in there.
Yeah, Melinda Shore. I am really enthusiastic about this. It looks great. The caveat that I'm sort of on the idea of providing guidance to the IETF. I think it can be implicit in the document, and that would be sufficient. Mm-hmm. Also, I'm going to disagree with Elliot. There are many examples of IETF protocols being used to disassociate people from the internet and from one another. And I mean, DNS is actually, we can come back to that, circle around to that, but DNS is a good example. So yes, yay. I mean, very nice.
Cool. I do think that there's a way to combine those two comments in the sense like Brazil platform blocking WhatsApp is also sort of a meta protocol block, right? In the sense that they have to do a whole bunch of protocol level stuff to do that, and then they start throwing people in jail. Sorry if you're from Brazil. But.
Okay, hopefully, Stefan, you're on now, so I'm going to let you go ahead.
Yeah.
We see you, so perhaps we'll hear you.
You could do a little interpretive dance.
Speak,
Stefan. Stefan, speak. You just went out of the field of view.
Please come back.
Nice bookcase.
We see you, Stefan, and we're waiting for you to say something.
He doesn't hear us, I don't think. He's doing all those movements you do when you don't hear.
We'll wait for the voice of God, aka Stefan. But Elliot, did you want to say something in the meantime?
Yeah, I was just going to say it. I stated those points as questions, so maybe Melinda, you disagree with the question, but I also like your refactoring of my question, Joe, to talk about the difference between platforms and protocols. I think that's a very useful way to put the.
Cool. I think we can do that.
Okay, Stefan, I don't know whether you're able to hear us and whether you're able to speak, but we do see you.
So you should be able to say something, and we will hear it. Say some words.
Not yet.
Say some words.
We see your mouth moving.
Oh, I saw some words, but I didn't hear them.
Can you just type your question or your statement into the Jabber room, and then somebody can come to the mic and speak. He is in Jabber, so thank you.
just hope I didn't.
Remote participation is a wonderful thing, especially when it works.
So Ludwig Seitz relaying Stefan's comments here. He says, I just wanted to say meeting for mid-December could be with X author.
Yeah. So sort of have a check-in with us editors, with the authors. Other people would be welcome to join, but that could be sort of a way to do that.
Fantastic. Yeah, don't pay any attention to my nervous Nelly.
No, I hear you, man. December is going to be chock full of fun stuff on my side, too.
Okay. So,
thank you.
Thank you. Okay, I guess I'm next. I'll stand on the red X. Wow. Short people time. Too short. I should not have moved it. Okay, so basically, this hopefully Niels is online and listening, because definitely he should intervene in anything I say, but so too with the rest. We've had discussions on this, and on the list, I said that I would try to do sort of a quick look at where we're at on this so that we could then look at going further. So the current state is the author and other people, and it's more than a few, many other people, have believed that the doc is ready for a research group last call. There's also been a number of people that have questioned that and have said perhaps not. A lot of people think it's a valuable piece of work that should continue, should eventually be published. There are a few people that have questioned that, and a very few have actually seemed against taking it forward. But I'd say that the majority of people that I've been listening to have said, yes, it's worth doing, it's worth taking forward. I think that Niels has done an incredibly admirable job turning around, I think, 3 or 4 versions in an attempt to respond to all the comments people are making in quick time. And so I really wanted to thank him for that. I also think that the conversation that has gotten going on the list by people trying to make their points and trying to make their points understood has been really good. It's kind of the thing I often look for in this group, is not just someone puts out a document, everybody nods, and then it gets published, but rather that some real conversation on the depths of issues happens. So I really wanted to thank the people who sometimes, despite their busy lives and whatever else, have done that. So thanks, and don't go away. So some of the issues. Now, these are the issues that I've sort of picked up in a brief form. Obviously, we've had well-spoken, erudite writers writing paragraphs and paragraphs, so I'm sure I did not capture it. We also, in Niels's many versions, perhaps some of these have been fixed, but I don't want to make the assumption until others have said. So there was a clarity on the research question. People were sort of saying, what is the research question that's being asked here? And can you make it clear in the document? It has gotten clearer. I'm not sure whether it's yet clear enough for all. There is a consistency between sections of the document with questions being asked. And here I'm quoting one of the people that commented, do networking standards have political use and or impact? Is there politics in the development of networking standards? Are protocols political? And those are statements that are all made. They're connected. Is the logic between them working within that framework? Are all the statements sufficiently substantiated with argument or references? Many, many are. I believe probably most are. Some may not be. Some may actually be, but the explanation may not be clear enough to everybody reading. I'm not judging here. I'm really just trying to sort of capture the things that were expressed. One of the questions that came up that had been in the draft was taken out of the draft, but others felt was still important, was should access to IETF, whether it's to the meetings, to the documents, to the whatever, be included in the discussion of the political nature. And there were lots of discussions on that. There was definitely a split in the viewpoint of it being critically important to it not being relevant at all, or to it being a confusing issue to include. There were issues with definitions. The term political, there was a single definition given for political, and yet I think almost as many definitions for political as we have in the room. So was that large span of definitions of political sufficiently covered? Is the definition of political that's in there adequate? Use of standard without a definition. In other words, there was talk of protocol considerations, there was talk of standards considerations. The comparison and the relationship between protocol and standard was not differentiated, and such. There was questions made of, are we talking de facto standards? Are we talking about de jure standards, if we could call an IETF standard a de jure? Also discussions of normative versus voluntary. Nothing in the IETF is indeed normative. It's all voluntary and recommended. So how does that fit in to this political analysis? There was the difference between non-standard protocols and standard track protocols. Does that make a difference in the political nature, in the political analysis? How does that work? Is it sufficiently defined in the document? There were questions occasionally about the logic of the document, and some very, very good bits of logic analysis that I'm not sure everyone necessarily agreed with, but logical analysis, you say A, you say B, you conclude C, but I don't see the connection between them. So basically, a clarification seemed to be asked for. Some of it was made. Does it work for people in the logical analysis of the document? Again, a similar question that came up in association. For whom is the document being written? And does it achieve that purpose? That is not clear. Is it for the IETF? I think personally that it's probably broader than that. But to whom, and does it achieve the purpose? There's a second page. Oh, yeah, that's right. I got the clicker. These were issues that sort of were issues that weren't necessarily in those. Perhaps they were mine. The abstract speaks of general agreement as opposed to an open discussion. I know every time I run into general agreement at the beginning of a document, I sort of freeze up a little, and I wonder how we substantiate that notion of general agreement. And I certainly haven't seen us get there yet on this one. There's an inconsistent referencing. Sometimes it's superb, and sometimes it seems a little short to me, and some more reference, some more depth could go. But I also must admit that there was at least one reviewer that said, there's too much referencing here. There's too many documents that I might need to go off and read. So how we find that balance is something to There was I'm looking for a reference on the term of affordance. I went and did some research on it, but I think since affordance was a critical term in this document, it would probably be good for it to have. One of the things that I haven't had a chance to check on, and so I'm asking, is are the terms that are used in this document consistent with the definitions that we've got in 8280 and consistent with the terms and the way they're being used in association? Looking at this from a shepherd point of view, from a co-chair point of view, I'm kind of looking to make sure that we've got consistent language across the documents, that when we use a word in one document, we don't have a different definition for it, unless we've been explicit about saying, hey, we're going to change the definition here because. It looked to me like the definition, that section 5, the discussion, was a little one-sided and really didn't represent the opposing views seemed more of an assertion than a discussion. Now, I'm not trying to say here in this analysis that it must be a consensus. What I'm saying is that it is fine for it to have an assertion of this is the point of view and we've proved it against the opposing views. Here are the opposing views and this is why they did not prevail. That kind of discussion that shows the back and forth that's gone on between various things. And then there's lots of typos. So my view on it is there still is work to be done before it went to a last call, partially because of the issues that all the other people have opened up and partially because of the issues that I've personally outlined. So first of all, as I said, I've been acting as the shepherd on this one. Not that we really had this notion, but certainly once it went to research group last call and went to the IRSG, it needs to be shepherded by someone. And I've sort of been putting myself into the place of that. But if there's a strong aversion to me being the shepherd on it because I may be too prejudiced in my opinions or what have you, certainly we can work that out. But at the moment, unless there's so I view the doc as needing to provide a strong basis for ongoing discussion and future research. That's one of the things that's sort of there, but not explicitly. You can implicitly find it in the document, but there isn't a clear in the conclusion. And this is how we move forward, and this is how it's useful, and this is the further research that can be done. And here I'm coming into the topic from yesterday's meeting, and it's a topic for later, the word consensus. I'm looking for consensus, as we had on 8280, that the document is clear for publication, that people look at it and say, yeah, I disagree with it, but my point is covered fairly. Yeah, I had a point there, it was discussed, it was covered. And not looking for consensus on it having a single view that everyone agrees to, because I don't think that that's actually possible. But I do think it is possible to achieve a document where everybody can say, yeah, that's fair. My point of view is expressed in there. I see it. I basically am looking for it not to be something that someone could confuse with a work of polemics, a work of arguing a point of view without having covered all the other points of view. We talked about adding an editor. No one's come through as a volunteer to work with Niels yet. I'm hoping that at least one of the people that had a lot to say and did almost as much writing in commenting as they might end up doing as a co-editor will actually volunteer. We had talked about replacing the editor. I have no ideas on that. I don't think it's necessary if we can find someone to work as a co-editor. And I'll stop. I think that was the last thing. Yep, that was the last thing I had. I'll stop to take comments. I don't know if Niels has a comment, and I can't go on too long because we've got to get Gershabad's document in, even if we don't get the rest of the discussion. So is there a comment for me? Or we can continue it on the list. But yes, I see two comments coming. We'll hold at those, and then we'll go to Gershabad and the list. No, one comment. Two comments. Okay, please.
Aubrey, thank you very much for that summary. I think you covered the ground really well. This is Elliot again. If you go back to your first issue slide, yeah. So I think a great many of these are just a matter of, really it's a matter of clarity of purpose and clarity of argument that had to be addressed. And that has always been my particular issue. The point about, let me help a little bit here. The point about should access to the IETF be included in the discussion, it's not a mandatory. We had that discussion, and I think people just agreed to disagree. And it's at the end of the day, whatever the editor did, one can cover it, one cannot cover it, and one doesn't have to cover every issue in every document. So as the person who raised the issue, I'm certainly happy to see it fall off if that's where people want to go. The issue around consensus is one that I think is probably worth just a little bit of discussion, a little bit of further discussion. in as much as we are clear as to what, how the room felt about the document in terms of, did everybody agree with the thing that was, with the result? And if we say, well, not everybody agreed with the result of this document, however, here's what we're producing. As long as we're clear in the front of the document as to the position, I think that's a perfectly fine way to go forward. But that having been said, I do think there is unfortunately the need for quite a bit of editing in the process that could help, I think, just improve the result. And I wish I had the time to help there myself, but I do not.
Okay, you beat me to my last question, which was, gee, after all that, are you volunteering? And then you beat me to it.
My fear, I wish I could, but I.
Gotcha.
Yeah.
Yeah. No, I'm just being more amused that you beat me to the question. Please.
Ludwig relaying comments from Jabber from NLLZ. Thanks a lot for this, Avery. This is very useful. For me, the author editor of the document, it would be great to have guidance from the shepherd what we have agreement on, either approaches and or arguments, and what needs improvement. Because sometimes it feels like we're going back and forth. Could we perhaps make a shepherd issue list, maybe taken from this presentation, and seek to address the issues one by one? Else, I am afraid we will continue having great discussions, but maybe not end up with a great final document. And I haven't seen any discussion on replacing the editor on the list. Could you please elaborate on that?
Right. Yeah, the replacement for the editor was something that came up before our last meeting, and as I just wanted to carry it for completeness to make it wasn't discussed on the list. I don't think that we have the issue, though I really would like to find a co-editor, and as someone who's playing the role of shepherd, I don't want to become the co-editor because then the roles are confused. And so hopefully we can find one. Taking this and expanding the list and perhaps pointing to some of the places in the email where these points are discussed sounds like a really good idea, and I'll certainly undertake to do that while I wave that while I'm talking, and certainly undertake to do that. So thank you, and we'll keep working on it. I don't want to continue the back and forth. I do want to find a goal. Thanks. Last person.
Hi, Colin Perkins. Thank you. I think this was a nice summary of some of the issues. On your last slide, you say you're looking for consensus that the document is a balanced expression of views, even if it concludes with a view that's not consensus. I think a balanced expression of views is a very good thing to have in there. I think a document which concludes with a view that there is not consensus on is a perfectly reasonable thing to do, provided it is clear whose view it is.
Could you repeat the line? Have a terrible time hearing on this stage.
The acoustics are terrible in these rooms. I think a document that concludes with a view on which there is not consensus is a perfectly reasonable thing, provided it is clear whose view it is making.
Right. And my only point on that, and it's a good time to talk, is that the group should see that statement and say, yes, we are fine with that with publishing it. And that's what I mean by consensus to publish without needing consensus on content.
Yes.
And that's really the differentiation that I'm trying to make.
Yes, and I absolutely agree with that. I'm just saying, if it is not a consensus product of the research group, be clear whose view it is expressing.
Thank you. That's good guidance. I like guidance. Okay, so that's it on this one, and we're really running late. But I don't think there's anyone in here right after us. We're just messing with people's lunch. So please to the next.
Yeah, so Gershabad is up. And also just a reminder, if you've not yet signed the blue sheets, you still have time to do that. And if you have the blue sheets near you, could you just raise them up so others can, there's one and there's one. Yeah, so please go sign those. Thanks. Go ahead, Gershabad.
I think you're in the same situation as me. Oh, here, the clicker. I shouldn't have spelled the clicker.
Hello. Yes, so Niels and I are editing the guidelines document, which is basically an update to the guidelines that were already there in RFC 8280. And last time we just discussed the changes that were made from version 2 to 3. And thanks to Joe and Abby for reviews, which we've already addressed. And there were some other updates there. Unfortunately, we didn't find the time to update it before this meeting, but a significant update is in the work and coming, which includes basically a rework of almost all the language in the draft to be applicable to networking solutions generally and not just protocols in the classic sense. And there are some places in the document where there is no explanation appended to guidelines, which we're working on now. And since the last meeting, there has been, I think, 2 points of feedback to the draft. One was by Karan, who said that the intended document status, which is on, let's say, IETF documents, it has an impact on how much adoption the draft has or how much impact it would make. And this was for a learning from DNS operations draft that Karan shared. So these 3 changes are coming up in the next version. And there's one question perhaps which we can discuss today quickly, which was brought up by John Curran in the list, that the right to legal remedy is also a human right. And what we haven't discussed in the draft till now is attribution. And therefore, how protocols can enable attribution, and so individuals who have grievances can seek legal remedy and get, I mean, attribution would basically help law enforcement track who created a certain piece of content, I assume. And obviously this has a conflict with anonymity and privacy, which is already discussed extensively in the draft. I didn't sense consensus on the inclusion of this in at least on the mailing list. There was some discussion about negative rights and positive rights, that the state not only has an obligation to not infringe on rights like privacy and freedom of expression, but it also has a positive obligation to enable that the right to legal remedy is enabled. And that is somewhat in favor of including a statement on attribution. And like my personal thoughts on this are that if you look at the MLS group, for example, or the OTR protocol, where deniability, which is the diametrically opposite to attribution, is a legitimate goal that is pursued for anonymity and privacy. So if you have any thoughts on this topic, on how to address this in the draft and how to include it, happy to listen to that. Otherwise, I will like ping the topic up back in the list. And yes, if you have any other suggestions to the draft, as always, and if you're using the guidelines to review documents, I'm very happy to incorporate your feedback into this draft.
Thank you, Gershabad. I just want to support teasing out some of those tensions, because that is really accurate in the framework of human rights, is that sometimes there are conflicts and there are nuance, and that's the whole point. So I think the document can only be made stronger by identifying where those tensions exist and actually trying to learn a bit more about them in the context of protocol and standards development. But I do think the best way forward is just to bring this up in the list and point people to the exact places where you might find some additional tensions.
Yes, I would say the problem in, well, not exactly a problem, the way the document is structured is in terms of questions, right? And while there is a lot of theory on how human rights would interact and are in conflict with each other, in a questionnaire sort of format, it seems like, oh, if I take this, then this is a cross. And perhaps we can then include a statement that, you know, this is, just use it as an indication of what you want to achieve rather than...
Yeah. Well, I just think because it's guidelines, right? Like if you're doing a similar thing for in a legal policy space, you really want to focus on those in a lot of ways, because that's where you can influence people making difficult decisions when it matters. So maybe if we have enough of these, maybe it's not just this case, but there are a couple of other tensions, we can maybe start to collect them in a separate section that is like, you know, sticky issues or particularly interesting things to pay attention to.
I'd
Like that.
actually love to see a separate draft on this. If I mean, I think it's a huge discussion. But yeah.
Not that we have any time, but anyone have a? Oh, you have open questions, and right, okay. So yeah, so please, you know, review that draft, and especially if you are using it somewhere, please contribute. The last topic we're not going to get to, I'll take it back to the list. It was, why do we insist on acting like an IETF group when we don't have to? And all I could say is that was the method we decided to use at the beginning. It was a notion of, gee, let's use a method that we're all comfortable with, and let's eat the same dog food as everyone else around us. But more than willing to change if we have a good reason to change. I know we don't have to operate like an IETF working group, but that doesn't mean that we can't. And so I'll stop there because it's time, and I don't see anybody running frantically for the microphone, but I do want to keep carrying it on the list.
I mean, I just had one comment on that while we were talking today, is I don't think all of our drafts are necessarily the same. I think that based on our charter, we have some really specific ones that we're trying super hard to, like a draft association. You can imagine one on freedom of expression, because those are specifically mentioned in our charter. Whereas political, I feel like, isn't necessarily like a core one, as an example, right? And maybe is even more like the way that what the draft is trying to achieve is even better suited for it being an opinion, because otherwise it's everyone's opinion, and then therefore it says nothing. But so just to think about the nuance of that, it's a case by case basis as well, no?
Yep. In fact, as I had said, if anybody ever wants to write an article for a journal that is not in the RFC status, then we could find a completely different method of working it. So anyhow, I still see nobody running frantically. We are over time. Thank you very much. Please be active on the list. Thank you to Jabber. Thank you to Note Taker. And talk to you. And do we have all the blue sheets? The blue sheets. I see 1,